Okay, this was an interesting, this was the 2011 data, graph size down at the bottom in equivalent terabytes, where at that point the equivalent terabytes was assumed to be about 280 bytes times the size, the number of edges, because that was about the average of the reference implementation. And what was important here was that the performance looked like it was flattening as we increased the problem size. This was something that David talked about earlier. This was the same data that I did with 2012, and the new values, and this guy out here is the Sequoia. Actually, both of those machines, both of the Q machines are under the same point. And it's unclear whether there is something extraordinary happening there or whether there still is a flattening. It'll be interesting to see as we go forward. And then I think the other point that was really interesting is how much memory are we using out of the entire installed memory of the system. So what I did was divide, take the problem size, compute the number of edges, and divide that into the installed memory as reported on the system. And what I got was a number somewhere between 1,000 and 3,000 bytes, which, if 280 odd bytes is about the right number for an edge, to express an edge in the reference implementation, that means we're using 3 to 4 times, there's 3 to 4 times more installed memory than there is memory used in the graph. So, but you got to subtract some of that out for operating system copies and other stuff. And I think, was there anything else you wanted me to do?
It's different
okay.
Number.
So that's it.
So I mean, the conclusion
got to take into account.
Peter, seems to be that all machines have trouble running this, even the superstars.
Right.
Okay. Well, thank you everybody for coming, and we'll have certificates outside for those of you who want to come up.
Thank you.